A useful tool for finite element modelling is the use of cross-sections. Using cross-sections, we need not explicitly create a geometry with the correct cross-section, and we can do it effectively as a sub-modelling approach. So we have a number of different cross-sections, or default cross-sections, which are available, as can be seen listed here. They range from rectangular and circular through to standard I-sections, T-sections, hat sections, and also some user-defined sections that can be generated as well, which we'll come to. But these are a way to generate and define different types of cross-sections without having them defined explicitly as far as the geometry is concerned. We'll explain a little bit more detail about how this is done. So cross-sections can be created directly from the context menu. Here we can see the concept menu. We drop down to the bottom option here, and we can see all of the different types of cross-sections that can be generated. A cross-section branch is inserted into the tree. This can be seen on the right hand side of the screen here, where we have this screen extract. We have 3 cross-sections generated: rectangular, circular, and a channel section. Once they've been created, we can then assign sketches to these particular cross-sections. We can highlight the cross-section in the tree to modify the dimensions. Here we can see some of the dimensions of the cross-section listed. They can also be seen graphically in the window, along with the naming convention for the dimensions, which are associated on the left hand side. In this case, W1, W2, T1 and T2. The cross-section dimensions can be repositioned using the right mouse button, and we can opt for move dimensions, and this will allow us to edit some of the dimensions of the cross-section. Once we've created a cross-section, we can assign it to an existing line body. This is when we start to close the loop on cross-section use. We simply highlight the line body in the tree, as shown on the left hand side, and a cross-section property appears in the details window, shown in the center. We can then select this field and drop down and select the cross-section that's been created. This will then assign the cross-section which has been created to that particular line body. It's also possible to create a user-integrated section, which can be defined in Design Modeler. This gives much more flexibility for more user-definable cross-sections that are needed. We have all of these types of inputs that are necessary, such as area of section, products of inertia, warping constants, and centroid and shear center information that can be inputted for user-integrated cross-sections. In addition, we can also create a user-defined cross-section from the concept menu, which is the last item listed in the cross-section types. A node with an empty sketch will be added to the outline tree, and we can click the sketch tab in order to draw the required sketch, but of course this sketch must be a closed sketch in order for it to perform the necessary calculations. And once we click generate, Design Modeler will then compute the cross-section properties, and the properties after that creation can no longer be changed, but then we can assign them to a line body following that operation.